Hi dear students, good morning all. Today in this video we are going to study about the chapter atom. What is atom? How it was discovered and all that information we are going to get this from this video. Atom was first discovered by J.J. Thomson by the help of experiment on electric discharge from gases which he conducted in the year 1897. He was conducting some of the experiments on the gases by discharging the electric charges onto it. Then he got observed that about the atom, and in the next year he gave the information about the atom, nothing but the construction and how it is there, the atom, how it consisting of neutrons and protons, like that. He got the information by the first model of atom, and he called that model as plum pudding model, because according to J.J. Thomson, the electrons are embedded in the volume of the atom, where the positively charged particles were uniformly distributed throughout the surface, throughout the volume, and electrons were embedded in it like a watermelon, in which watermelon consisting of seeds which are distributed in the plum. So likewise the electrons are embedded in the atom, in which positive charge are uniformly distributed. So this model of atom is called as plum pudding model, nothing but first model of an atom. Then after his student, J.J. Thomson's student, what he did, nothing but Rutherford, in the year 1906, he continued the study of related to atom and gave the second model of an atom, which is called as nuclear model of an atom or planetary model of an atom, according to which the atom is consisting of a nucleus. Nucleus was discovered by Rutherford, because where nucleus nothing but it is a concentrated positive charges and electrons were revolving around the nucleus. This model of an atom was given by Rutherford, which resembles the solar planet or any planet system, nothing but sun at the center and planets revolve around the sun. Similarly, here the positive charge is concentrated at the center and the negative charge particle, electrons, will be revolving around the nucleus. So this model is called as planetary model of an atom or nuclear model of an atom. This model of an atom was given by Rutherford with the help of experiment, that is alpha particle scattering experiment or nuclear model of an atom. With the help of this experiment, he gave the structure of an atom. How it works, what are the experimental setup, let us we shall study about it. Okay, this is the schematic representation of alpha particle scattering experiment which was conducted by Rutherford, according to which it consisting of lead sheet in which a source of alpha particle is used. A source of alpha particle, nothing but a radioactive source which emits the alpha particle. What is alpha particle? It is nothing but helium atom. The radioactive substance which emits alpha particle, nothing but helium atom, that is being used in the lead shield alli use madidare. Why? What is the purpose of using the lead shield? Because the radioactive substance will be emitting the alpha particles in all direction 360 degree, but we need a alpha particle is to be projected on some of the gold foil, so it is to be collimated, nothing but it has to be made to move in a single direction. So the lead shield is used through which the alpha particles were collimated onto the gold foil of thickness 2.2 into 10 raised to minus 7 meter. The beam was projected onto gold foil of thickness. What is the purpose of using this much small thickness of gold foil? Which means if I use a larger size of a gold foil, what happens? The number of atoms will again increases. So the interaction between the alpha particle and the atom would not be studied easily. So Rutherford what he did? He reduced the size of the gold foil to this much thickness, 2 into 10 raised to minus 7 meter. And then he collimated the alpha particles and projected onto the gold foil. After, what happens if the projected gold foil, if the collimated gold foil is projected onto the gold foil, what happens? They will scatter in different direction. That scattered radiations from the gold foil will be detected with the help of scintillator. Scintillation means light, form of a light. So what happens when these scattered radiations of alpha particles reacts with the screen, which consisting of ZnS, zinc sulfate. This screen will be having this one, the ZnS. So when these alpha particles react with the ZnS, they form a light. Photons, nothing but in form of photon, it forms a scintillation. Process of forming light is called as scintillation. These particles, after reaction with the ZnS, what happens? They form the light patches on the screen. Through these patches, we can conclude that the alpha particle which is projected onto the gold foil is collimated in this direction or in any of the other direction. So this is using this setup, what happened? Rutherford gave the idea of the atom. So these are some of the experimental setup. Scattered alpha particle were detected by ZnS screen. I told you that. For different angle of incidence, number of scattered particles were measured. Then what happened? He varied the angle of incidence. Goes on increases, or for different angle of incidences, what happened? He studied the number of particles which are get scattered. With the help of that graph, he concluded some of the points. He observed some of the things. Those are listed there. First one is about most of the alpha particle were passed without any deviation. Without any deviation, what happened? The projected alpha particles were passed. From this, he gave the idea that atom consisting of large amount of free spaces. How he concluded that? So let us experiment it. First, if it is an atom, okay, this I will consider it as an atom. I am projecting some of the alpha particles. The collimated beam of the alpha particles were passing through the gold foil. So here there are some of the gap. So through that gap it can pass through easily. If there any obstacle, what happens? The alpha particle will stop. Since they passed easily, which means there must be some space. So most of the alpha particle passed without any deviation, which means atom consisting of large number of free spaces. Okay. Then he observed that about 0.14% of the incident particle scattered through large angle. So if I am considering this as an atom, this one as a nucleus. Nucleus was not yet discovered. From this experiment only it was discovered. Okay. When projected alpha particles comes nearer to the nucleus, what happened? Due to the positivity of the nucleus, they little bit scatters. They deviate from its original direction. Adar original direction inda adenagutte ಸ್ವಲ್ಪ deviate agutte. So about 0.14% of the scattered incident particle they scattered through the large angle. Next one, about 1 in 8,000. 1 among 8,000 incident particle, the alpha particle scattered by more than 90 degree, means there are more number of 8. If I consider 8,000 particles were projecting on the gold foil, what happens if I consider one atom? Okay, they are projected onto the gold foil. Among these 8,000, one is reflected back or deviated by more than 90 degree. From this we can conclude that the atom consisting of the positive charges, if I consider it as an atom, and it consists of the positive charges at the center. The positive charge is concentrated at the center. Okay. Similarly, then if I projecting some of the collimated alpha particles are nothing but helium atom which are positive in nature. If they are projected onto the onto the atom, what happens? Since there are some free spaces, there are more free spaces in the atom, they get easily passed due to the free space. The most of the particle pass through without any deviation. Next, about 0.14% of the incident particle, they got scattered through Lagrange angle, which means the atoms nearer to the alpha particles which moves nearer to the nucleus, what happens? They got scattered. They deviated from the original direction. This was the original direction. They got deviated due to the presence of the nucleus. Why it happens? Because alpha particles which were projected, they are positive in nature, and the nucleus nothing but the concentration of positively charged particle. So positive, what happens? They reflect. So the alpha particle when reaches the nearer to the nucleus, they got deviated. And third point, 1 in 8,000 scattered by more than 90 degree. If I consider one atom in 8,000 one alpha particle which is directly onto the nucleus, what happens to it? Positive and positive interaction, what happens? They repelled or they reflected back in its own direction. So this is some of the experimental setup and what are the observations made by the Rutherford. So Rutherford, this model of atom was called as nuclear model of an atom because there is a presence of the nucleus is known. It was known, and it is known to be planetary model because nucleus is present at the center and electrons will be revolving around the nucleus, and there are some of the spaces, free spaces. Most of the particle pass to the from this point. We got that there are more free spaces and the positive charge is concentrated at the center. And about 1 point, these are some of the observations through which we got the structure of the nucleus. Okay, these are about the some of the introduction. First model of an atom, nothing but J.J. Thomson gave the first model, that is a plum pudding model. Next, after his student only, that is Rutherford, continued the study of J.J. Thomson about the atom and gave the clear structure of an atom. Next, in the next video, we shall going to study about the theory of these concepts. From these observations, what we can conclude, that all we shall going to study in the next video. Thank you.